Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutewa Sos Ukobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have question 7. Still on differential calculus, and then it says 7.1, determine f prime x from first principles if f of x is equals to 2x squared minus 1. Right, now at this point we know that we should first check f prime x, and then this is 2 multiplied by 2, that's 4x. And then obviously if we are to find the derivative of a constant, and then the derivative of a constant is just 0, so we're just gonna leave it like that. So that means our f prime x according to rules must be 4x. But then you will have to remember that we are not solving this in terms of the rules, we are solving in terms of the first principle. So now you get to the drawing board. Your f of x is 2x squared minus 1. Then you need an expression for fx plus h. What this means is that where there is x, you have to replace by x plus h, then square that minus 1. Now this one, we know that it expands to x squared plus 2xh, then plus h squared minus 1, right? This point you want to multiply inside with the 2, so that's 4xh, then plus 2h squared, then minus 1, right? Okay, now you take this whole expression. If your f prime x is equals to lim h approaching 0, fx minus f of x over h, right? And then now you have your lim h approaching 0. You take this whole expression for fx plus h, which is 2x squared plus 4xh plus 2h squared minus 1, then minus the f of x, which is 2x squared minus 1 over h. Now at this point, what do? Know that these ones will cancel out. The negative 1 will cancel out with the negative 1 because eventually it will come out as a positive. Right. Then let's continue. Again, do not forget your lim h approaching 0. We have 4xh plus 2h squared over h. This point, looking at the two terms, we can see there is a common factor of h. So we do what? We factor out that h. So we have h 4x plus 2h over h. This point, we know that the h and h will have to divide out, and then we are left with that expression there, which at this point we can deal away with this lim h approaching 0 by simply replacing 0 where there's h, right? Now, therefore, our f prime x is equals to 4x. And is it correct? Yes, we have confirmed it above there. So it is correct. You have your 5 marks as easy as that. Easy peasy, lemon squeezy. Okay, so we have determine 7.2.1, d of d dx, and then that. So now you have to be careful with this notation here. So if you are given that, first thing that you have to do is you prepare your expression for derivation. Again, looking at this, we can see that that is in SAT form. And then we know our one of the 10th commandment of a derivation is that do not derive while it is still in SAT form, right? So it's really 2 commandments, really. Then x 2 over 5, because we know it's the exponent of the variable over the exponent, over the number here that's for the root, then plus x to the exponent of 3. So at this point, if it's now prepared for derivation, check what we now do with this notation. We now change it and say dy dx. So this is indicating that we are now deriving, right? So take the exponent, jump down to multiply the coefficient of 1 here. So it will just be 2 over 5 and then x. If we subtract 1 from here, this is going to be negative 3 over 5. And then from here, take the exponent, which is exponent 3, jump down to multiply here. This will be 3x. If we subtract 1, this is 2, right? So it's only 3 marks because number 1, we first prepared it for derivation. Then number 2, we derived this, right? So that's how you were supposed to go about answering that question there. Okay, so now let's go to 7.2.2. We have solve f prime x if fx squared minus 9 over 4x plus 6. We must find our f prime x, right? Now they throw a little restriction there to say that our x should not be equal to negative 3 over 2. Now every time where they do this, we know that it's because if we substitute that particular value into the equation, then the equation will just be not applicable. It will just go in error meets error. So that means it will be undefined. Yes, undefined is the way that I'm looking for. So undefined or non-real. Right. So that means if we substitute that x coordinate there, we would have to get an undefined solution or an unreal solution. So if you can even try it there and then just try to negative 3 over 2 in where there's x there, and then you punch it into your calculator, it will just go maths error. Right. So that is a restriction. You are not really supposed to do anything about it because we are not trying to solve for x here. Right. So that restriction, you just acknowledge it and then ignore it at the same time. Right, so now we have 4x squared. Our f of x is equals to 4x squared minus 9 over 4x plus 6. Now, at this point, you don't want to derive, right? Because you can see that it is not prepared for derivation. So this is more of a simplified type of question, a factorize and simplify type of question, more than it is actually deriving. So that's one thing that you have to note about these questions. It's not always derive. They kind of throw in the mix of having to factorize and simplify, expand, and all that. So you need to be very careful when you're dealing with some of the questions there, because now in your mind you have this thing of you want to derive, and then you end up not seeing that first you need to factorize and then maybe find the common factor and all those things. So these are some of the questions where you need to do that. Now, looking at 4x squared minus 9, we know the 4 is a perfect square and the 9 is a perfect square. And as our middle term here, or in between the terms here, we have a minus sign, which obviously this leads us to DOTS, difference of two squares, right? So difference of two squares will give us 2x, because if we square the 4, it gives us 2, and then if we square the 9, it gives us 3. So that's 2x minus 3, and then 2x plus 3. So this is how we figure out a difference of two squares. We know it will be the same. It will be the same terms in both of the brackets, but then the only difference is with the signs. And so here the sign is negative, and then here the sign is positive. And then below here, remember, if we are working with questions whereby we have to factorize, especially in a case whereby we have fractions, we know that in most of the cases we are looking for a way in which we will have to cancel one of these expressions above here. So looking at 4 and 6, we can see that there is a common factor between 4 and 6, which we can all agree it is 2. So we can factor out 2. And then obviously from the 4, if we factor out a 2, 4 divided by 2, that leaves us with 2x. And then if we factor out a 2 from 6, 6 divided by 2, that will leave us with 3. Now you can see what I've been trying to tell you, that every time we are in a fraction and then we are trying to factorize, then one of these two things will happen. So it's either we will have them cancelling out, or maybe we will have to try to figure out a common factor that will then cancel out. So at this point, we can see that here, this is the 2x plus 3. And then also we have the same expression above, 2x plus 3. So those ones can just divide out. And then remember, we haven't derived at this point. So this will give us f of x is equals to 2x minus 3 over 2. Haven't derived, so our f of x, if we express this, remember this means that 2 divided by 2 and also negative 3 divided by 2. So this can be expressed as 2x over 2 and then also as negative 3 over 2, right? Because this means 2x minus 3 all over 2, so they all have the denominator 2. Then that's f of x is equals to x, because 2 divided by 2 is 1, and then this is just negative 3 over 2. But then remember, let's not get carried away with all the factorizing and simplifying. Remember that we are looking for f prime x. Now that our expression is prepared for derivation, we have dealt away with the factorizing part and the simplifying part. That's when now we can derive and then say therefore our f prime x. Obviously at this point we can see the derivative that we are going to get is from here, right? So which is just a variable with an exponent of 1, meaning the solution has to be the coefficient. So that's 1. Obviously if we try to derive this one, it's just 0. So we have our derivative as only 1. Okay, so and that's how you were supposed to go about tackling this question there, all for a total of 12 marks. So please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.